HVAC temperature rise formula for measuring airflow CFM is simple. CFM equals the heat input in British thermal units per hour divided by the product of specific heat of air and the measured temperature rise. So get accurate supply and return temperatures, and you get reliable airflow numbers fast. To measure airflow correctly, start by calculating heat input precisely. For gas furnaces, measure manifold pressure and gas flow or use the equipment nameplate input, and for electric furnaces, total the wattage on each element. Then compute CFM using the formula CFM equals heat input BTU per hour divided by 120 times the measured temperature rise in degrees Fahrenheit, where 120 is the product of specific heat of air and pounds per cubic foot standardized. Always measure temperature rise with thermistors or infrared sensors that have been field calibrated against a reference. Take 3 measurements at the supply and 3 at the return, average them, and use the midpoint of the supply plenum for consistency. Seal all register boots and close all bypasses so the furnace is operating in normal configuration, and run the unit at steady state for at least 10 minutes before recording temperatures to avoid transient error. Account for venting losses or secondary heat by correcting heat input when flue gas temperatures are high or when combustion analyzer readings show incomplete combustion. When using electric element totals, subtract blower motor input power if the motor is on the same circuit to avoid overestimating heat into the airstream. Document ambient conditions, altitude and indoor versus outdoor temperature, YSCF. Because air density affects CFM, apply a density correction factor when above sea level. If the calculated CFM is outside the expected range, repeat the measurements and inspect for dirty filters, duct restrictions, or collapsed flex runs, which are common hidden causes of low airflow. One of the most frequent problems is inaccurate temperature measurements caused by poor sensor placement or uncalibrated thermometers, which you fix by using calibrated probes inserted into drilled ports or held with spring clips in the airstream, and by verifying against a certified reference. Another common issue is air leakage through the blower motor compartment or return plenum that skews CFM readings, and the remedy is to temporarily seal the blower motor compartment with non-conductive cardboard held by magnets, or with cloth back tape plus cardboard, or to fit a carefully cut sheet metal panel that does not contact wiring. The third widespread mistake is failing to account for blower motor electrical draw on electric furnaces, producing an overestimated CFM, solved by measuring motor wattage with a true power meter and subtracting that from total element input when calculating heat transfer to the air. BigHomeProjects.com lists trusted local HVAC contractors and includes contractor profiles that show who is experienced with professional airflow diagnostics and temperature rise testing. The directory helps homeowners find qualified technicians and gives contractors visibility to win work from informed clients.